Section 3.1, we talked about quadratic functions and models. And our general quadratic equation is the quadratic equation f of x is equal to ax squared plus bx plus c, where a cannot equal 0, otherwise it's not a quadratic function. Now, when we have quadratic functions, one of two things happens. Either we have a parabola that opens up, or we have a parabola that opens down. The highest or lowest point on a parabola is known as the vertex. And the vertex is going to occur at either a maximum or minimum value, depending on how the parabola opens. If the vertex is at the bottom of the graph, it occurs at a minimum. And if it's at the top of the graph, it occurs at a maximum. Without needing to graph the quadratic equation, we can always tell if the parabola will open up or down by looking at A. If A is positive, the parabola opens up. If A is negative, it opens down. There is this line that goes smack dab through the middle of the parabola that cuts it in half. That's called the axis of symmetry. And the axis of symmetry has its own equation. X equals the opposite of b over 2a. So if you can find the axis of symmetry, you'll know the x coordinate of the vertex. To find the y coordinate, you can just plug that number back into the original function in order to find y. Now, there's another useful form of equation of a quadratic, and it's called standard form. It is also sometimes called vertex form, and it's the equation f of x equals a x minus h squared plus k. And this actually looks very similar to the parabola equation that we used when we did conics, which was this. This is one of the two equations. And the vertex of our equation is going to be at hk. And again, if A is positive, it opens up. If A is negative, it opens down. So one of the things that we're going to do is we're going to talk about how to put a quadratic equation in standard form. So let's do an example. Let's put f of x equals 2x squared minus 12x plus 23 in standard form. This is how it's going to work. First, you're going to take the first two terms of the trinomial and separate it from the last term. Now, when you do that, we're going to do a process called completing the square, and that's how we're going to fill in this blank that I just put inside the parentheses. But in order to keep an equation balanced, if you add a number to an equation, you must also subtract it. Now, I can't complete the square unless the leading coefficient in the parentheses is a 1, which it isn't. So I'm going to factor out a 2 from those two terms before I go about completing the square. Now I'm ready to complete the square. The way we completed the square was we took the middle term and we divided it by 2 and squared it. 6 divided by 2 is 3. 3 squared is 9. 9 isn't the number that goes in the last blank. The last blank is actually 18. It's 2 times 9. Remember, we had actually factored out a 2 before we knew what that blank was. Now, in proper vertex form, this is going to be 2x minus 3 squared plus 5. When you put this perfect square trinomial that we just created in factored form, it's always the square root of the first term, square root of the last term. The sign between them is the sign on the middle term, and it's squared. And now that's a very useful form because I know that the vertex is at 3, 5, and I know that the parabola opens up. Let's put f of x is equal to 5x squared minus 30x plus 49 in standard form. But let's also find the maximum or minimum value, depending on which one it has. All right, I'm going to start skipping steps now. Since I'm going to take out the first two terms, and I need the leading coefficient to be 1, I'm going to factor a 5 from the first two terms before I put my blank. Now I'm going to fill in the blank. The middle term divided by 2 squared is 9. This blank is going to be 5 times 9. So in standard form, it's going to be 5x minus 3 squared plus 4. Since the leading coefficient is positive, this graph opens up. So the vertex is at a minimum. The minimum is the y-coordinate of the vertex. The vertex is at 3, 4. So the minimum value is 4. Let's do another example. Put f of x is equal to negative x squared plus x plus 2 in standard form and find the max or min value. Alright, so f of x is equal to, I'm going to skip a step again. Because the leading coefficient is negative 1, I'm going to factor out a negative 1 from the first two terms. And I'm left with x squared minus x and plus a blank. And then my plus 2 goes on the outside, minus blank. The number that goes in the blank this time, since the middle term is negative 1. Negative 1 divided by 2 is negative 1/2, squared is positive 1/4. The number that goes in the next blank is negative 1/4, because you have to do negative 1 times 1/4. Even though this is a fraction, it works the same way. When you go and put it in factored form, you take the square root of the first term, the square root of the last term, and the sign between them is the sign on the middle term. And then on the outside, 2 minus negative 1/4, which is 2 plus 1/4, which is 2 1/4, or 9/4. So there's standard form. Now I need to find out if it has a max or min value. Since the leading coefficient is negative, the parabola opens down, which means that the vertex is at a maximum. The vertex is at 1/2, 9/4. So the maximum is 9/4. Another way to find a maximum or minimum value of a quadratic equation is to instead find something called the axis of symmetry. The axis of symmetry, that line that goes down the middle of the graph, also tells you the x-coordinate of the vertex, and the formula is x equals negative b over 2a. So if you want to find a maximum or minimum value, then you just plug in that value back into the original function, and it'll tell you that max or min value. In this example, let's find the maximum or minimum value of each quadratic function. Let's start with the first one, f of x equals x squared plus 4x. To find the max or min, I don't need to put it in standard form. I could just use this formula, which is the opposite of b is 4 over 2 times a is 1. Negative 4 over 2 is negative 2. Then to find the y value, you plug in negative 2 for x. So negative 2 squared plus 4 times negative 2 is 4 minus 8, which is negative 4. Is that a maximum or minimum value? Well, the leading coefficient is 1, so it opens up, which means that this is at a minimum. For the next one, x is equal to the opposite of b is 4 over 2 times a is negative 2. Negative 4 over negative 4 is 1. To find the max or min value, we plug 1 back into the original equation. So negative 2 times 1 squared plus 4 times 1 minus 5 is negative 2 plus 4 minus 5, which is negative 3. Since the leading coefficient is negative, that parabola opens down, which means the vertex is at a maximum. Now let's do a real-world problem. Most cars get their best gas mileage when traveling at a relatively modest speed. The gas mileage M for a certain new car is modeled by the function m of s equals negative 1 over 28s squared plus 3s minus 31, where s has to be between negative 15, not negative 15, positive 15, sorry, and 70. where S is the speed of the car in miles per hour and M is in miles per gallon. What is the car's best gas mileage, and at what speed is it attained? Well, when they want to know the best gas mileage, they're looking for the maximum value of this function. And at what speed is it attained? That's the x-coordinate of that maximum. In other words, they want to know where's the vertex. Well, the best way to find it is to start by finding the axis of symmetry. Well, this equation doesn't use x, it uses s, but s is the same as the input. So we're going to do the opposite of b over 2 times a, which is negative 3 over negative 1 over 14. And when you divide by a fraction, it's the same as multiplying by the reciprocal. So we end up finding out that the best speed to get the best gas mileage is 42 miles per hour. To find the best mileage, you're going to plug 42 back into the mileage equation. So negative 1 over 28 times 42 squared plus 3 times 42 minus 31. And I'm just going to plug that into my calculator to find out the answer is 32 miles per gallon. So in order to get the best gas mileage out of my new car, it's best for me to drive 42 miles per hour, and I'll get 32 miles per gallon. A hockey team plays in an arena that has a seating capacity of 15,000 spectators. With the ticket price set at $14, average attendance at recent games has been 9,500 people. A market survey indicates that for each dollar the ticket price is lowered, the average attendance increases by 1,000. This should say the. Find a function that models the revenue in terms of ticket price. Find the price that maximizes the revenue from the ticket sales, and what price is so high that no one attends, and so no revenue is generated. Well, let's start with the first part. How do you find the revenue generated? Well, the revenue generated is going to be the ticket price times the attendance, or the number of tickets sold. Well, we want to change that ticket price, so let's start with this. Price times attendance. The price of the ticket was $14, and when the price is $14, we averaged 9,500 spectators. We want to lower the price by $1. Well, when that happens, we're going to add 1,000 people. X does not represent the number of tickets sold. X represents the number of price drops that occurs. So remember that when we go and do this problem. So here's my equation that best represents the situation. In part B, we want to find the price that maximizes the revenue from ticket sales. So the best way to do this problem is to really just graph it in your graphing calculator and change the window so that you can see what's going on. Once you do that, you use your max function under second trace to find where the maximum is at. Well, you're going to find out that the maximum attendance occurs. So the answer you get in your calculator is you get the maximum at 2.25, and then the maximum revenue is $138,062.50. Now remember, I just said that this is not actually the price of the ticket. That's the number of price drops, or that's the amount of the price drop. Basically, it says if you drop the price $2.25, every time you do that, you get 1,000 more people attending. So the ticket price is actually going to be 14 minus 2.25, which is $11.75. So when you sell the tickets for $11.75, you'll get a maximum revenue of $138,062.50. Now the last problem says what ticket price is so high that no one attends and no revenue is generated. Well, that we want to find the x-intercepts. So let's use our graphing calculator to find that. There are going to be two x-intercepts, and one of them is over here at negative 9.5. And then the other one is, let's see, I'm going to figure this out real fast. Other one, is at 14. Well, remember, as we go this direction on the graph, the price is dropping. So if the graph goes the other way, this is adding to the price. So to find out what ticket price is so high that no one attends, we're going to use this number here and add it to the 14. So 14 plus 950 is going to be $23.50. So apparently if the price of the ticket is $23.50, no one's going to attend.